Hey folks, today's topic is matrix operations. We first should talk about what a matrix is. A matrix is any array of data. Now, most of our matrices will look like this, but you've seen matrices before when you do Google Sheets or if you do an Excel spreadsheet. Those are matrices. So we're going to talk about some of the calculations, some operations that are involved with matrices. So the first thing I want to talk about is the characteristic of a matrix, which is the number of rows and the number of columns. So that's what we call the dimensions of a matrix. We usually use capital letters to identify our matrices. You might see the word order in another course. I'm going to just call them dimensions. So we have two characteristics that we look at. We look at the rows by, remember that X symbol like a 2x4? Rows by columns is how we write this. Now, how to remember rows and columns, that's kind of up to you. This is how I remembered it when I was a kid. I remembered that rows are like the things in church, the pews that go across the front of the church. And then columns are what holds up the ceiling. So I think of the, is it the Parthenon? Is it the Parthenon that has the columns up in front? I think so. Well, let's do a quick little Google check. Yep, there you go. There's a picture of the Parthenon. Those are the columns. So columns go up and down. Excuse me again. Columns go up and down, and rows go left and right like the pews in church. So rows go this way, like the rows of church. There's me up in front teaching you guys. There's the rows in class. So 1, 2, 3 rows. Then we use this X symbol to indicate by. So 3 rows by, and then there's 2 columns holding up the ceiling. So this is a 3x2 matrix. So let's talk about the easiest calculations. As always, we like to do add and subtract first. And adding and subtracting is exactly how you would think. It goes kind of just in order. I mean, if I was going to ask you, who would you combine -1 with? Well, you would combine it. My guess would be that term and then this term. So what's nice about matrices when you add them up is they always have the same dimensions. So my answer matrix, if this is a 2x2, a 2x2, and a 2x2, then my answer matrix is going to be a 2x2. So this first spot is calculated by adding together. This is called row 1, column 1. This is called row 1, column 2. Row 2, column 1, and row 2, column 2. So let's go ahead and add together corresponding, what do we want to say? Corresponding cells or elements, maybe. -1 subtract 1 is -2 plus 0 is -2. Then I'm going to move on to row 1, column 2. Row 1, column 2, row 1, column 2. So 2 take away 3 is -1. -1 plus 5 is +4. Row 2, column 1, row 2, column 1, row 2, column 1. 0 take away a -1 is actually a +1. And then a +1 plus a -1 adds up to 0. And then last but not least, row 2, column 2, row 2, column 2, row 2, column 2. 1 take away 2 is -1. -1 plus 3 is 2. There you go. You try the next one. Well, hopefully you didn't try too hard, because you'll notice that these two matrices do not have the same dimensions. And you must have the same dimensions to be able to add row 1, column 1, row 1, column 1, row 2, column 2. Sorry, row 1, column 2, row 1, column 2. Everything's good until we run into row 1, column 3. There is no corresponding piece. This is not possible. It's not possible to add these matrices together. So our little note here, to add, subtract matrices, they must have the same dimensions. To add or subtract matrices, the matrices must have the same dimensions. All right, moving on. So we've talked about how to add and subtract matrices. Well, what are these numbers out front? These are what we call scalars. So I'm going to circle the 3. I'm going to circle the 2. These are what we call scalar multiplication. That just means everything in matrix A is going to get multiplied by 3. Everything in matrix B is going to get multiplied by 2. Now, you can't have it both ways. If you want to take the subtract and treat this as a -2 and put this as a -2, that's fine. But then you got to have a plus in the middle. Let me do the first one. It probably doesn't make much sense what I'm talking about. Let's do them in order. So I've got 3 times A. That means everything in matrix A is going to get multiplied by 3. So that becomes 6. That becomes 6. That becomes 12. That becomes -9. That becomes 0. That becomes -3. Now, this is what I'm talking about. If you want to treat this as a -2 and multiply everything by a -2, then you must leave a plus in the middle. You can't leave the negative here and take the negative and give it to everything in the group, because then you've got 2 negatives, which would actually be a positive. So I leave the minus in the middle. And then I just take everything in the second group and I multiply it by 2. So that would be 4. That would be 0. That would be -6. Then that would be 2. That would be -8. And that would be 6. So I just multiplied everything in matrix B by a 2. Now I've got a 2 by 3 and a 2 by 3, so they have the same dimensions. That means that I can just subtract corresponding terms. So 6 minus 4 is 2. 6 minus 0 is 6. 12 subtract a negative, that actually adds, so that'd be 18. -9 subtract 2 is -11. 0 subtract -8 is +8. -3 subtract 9 is, -3 subtract 6 is -9. So, I'm going to show you how to do this on your calculator. It's up to you if you want to. Most of the time, it's faster to just actually finish the problem on your own. But I'll show you just in case you'd rather use the calc. So what I'm going to do here is I'm going to now create matrix A and matrix B. So if you look above x to the -1, x to the -1, there's the matrix option. So I'm going to select matrix. I'm going to go over to edit. Now look, I've already got some matrices in here. That's fine. It's fine. Yours maybe doesn't have anything in there. That's fine too. But because I want to create this A matrix, I need to edit, not names or math yet, edit. So my matrices have 2 rows by 3 columns. So this is a 2 by 3. And what's nice is your matrix then should look exactly like the matrix that you're trying to create. Now I'm going to input the values 2, 2, 4, -3, 0, -1. So now I've made the A matrix. Let's quit out of this, go back into matrix and make the B matrix. I forgot to hit edit. Go over to edit. Now look, you got to go downward. Don't stay up in matrix A. We're trying to make matrix B this time. Now this is nice. This already is a 2 by 3, so I'm going to leave that in there. 2, 0, -3, 1, -4, and 3. So now I've created those 2 matrices. I've told my calc what those 2 matrices are. Exit out, and we want to do 3 times matrix A, subtract 2 times matrix B. So 3 times to select matrix A, you go back into matrix, and then now we use this names option. Underneath names, if you just hit enter for 1, it'll put A in your equation or in your calculator. Subtract 2 times, and now I need to go back and get matrix B. So second matrix, names, because I want to actually use the matrix. I've already created it. And then this should spit back 2, 6, 18, negative 11, 8, negative 9. So look, I don't really care which way you do it on these. The problem is when I get to something like this, you're not going to be able to input it into your calculator. So you do have to know how to do it both ways. You have to know how to do it by hand, because if there's a variable, you have to be able to solve for what that variable is. But on the other ones, I'm fine. If you think it's faster, I kind of argue that it's probably quicker to just do this in your head. But if you think it's faster to make these on your calculator, that's fine. That's fine. All right, so what do we do when we have this situation where there's variables? So I can't put this in my calc to figure out what X and Y are. Well, think about what we're doing. We're just subtracting two matrices that are getting multiplied by scalars. So I'm going to circle the variable that I want. I want to go after X. Who corresponds to X in this place? The 5. Who corresponds to X in the answer matrix? Also the 5. So those three things are related. I can now use those to make an equation. Now this matrix subtract this matrix should end up being this value. So that means negative 3 times X subtract 2 times 5, which is 10, should end up being 5. Now this is an equation that I can use algebra to solve. So I'm going to bump over the 10. I'm going to divide by the negative 3, and I get X equals negative 5. Now I'm going to do the same thing, but I'm going to do it for the Y variable. So I'm going to circle the Y. That's the term that I want. So corresponding term in the first matrix is the 3. Corresponding terms in the answer matrix is the 7. So then I'm going to use my scalar multiplication to make an equation. Negative 3 times 3 is negative 9. Negative 2 times 2y is negative 4y. And then that should end up being 7. Bump over the 9, negative 9. What's that, 16? Divide by the negative 4, and we get y equals negative 4. Now, if you want to at this point, you could check. I'm pretty confident that we did it correctly. But let's just show you that you could check. I'm going to... I wonder if my calc will die here. I got to go get new batteries before my next video. If you have fancy calc, you can go alpha. I think it's F4. Nope. Alpha F3. See where it says matrix here? Alpha F3. And then you can decide what kind of matrix you want. So I want it to be a 2 by 2. Oh, shoot. You got to put the negative 4, negative 3. So negative 3 times. And then I'm going to make matrix alpha F3. I want it to be a 2 by 2. And that's a 2, a negative. That didn't work. Second, enter. All right, that should be a 2. That should be a negative 3. That should be a 3. And then we solve that to be a negative 5. Subtract 2 times, and then I'm going to make another matrix, alpha F3. This is also a 2 by 2. Negative 4, negative 1. So we said y was negative 4. You got to be careful. So that means this would be negative 8. Because 2 times negative 4 would be negative 8, and then 5. So this should give us our... Where did I mess up? Negative 3, 2, negative 3, 3. Oh, I messed up in my actual making my matrix. The only one that's wrong is the one up in the... So this should really be worth... That's negative 9 plus 2. Wait. That's 9 plus 2. That should be 11. Oops, my answer matrix is wrong on the paper. I'll have to fix that. Ooh, okay. Yeah, pretend like... Avert your eyes. Pretend like that didn't happen. Okay, so matrix, we've done matrix addition, we've done matrix subtraction, we've done scalar multiplication, and now we're going to do actual multiplication. So we have two matrices that we want to times together. So the first thing you have to do is check to see if the multiplication is legal. Similar to the front, when we were adding and subtracting, the matrices all had to have the same dimensions. When it comes to matrix multiplication, it's a little bit stickier. So let's look at the dimensions of this matrix. This has 1, 2, 3 rows and 2 columns. This is a 3 by 2 times, this is 2 rows and 2 columns. This is a 2 by 2. For you to be able to do matrix multiplication, the rows, the columns of matrix A must be the same as the rows of matrix B. So these two inside numbers have to be the same. Otherwise, because what we're going to do is we're going to take this row and we're going to times it by this column. That's only going to be legal if the number of columns of matrix A is going to be the same as the rows of matrix B. Now, if that's true, then these two numbers end up being our answer matrix. So that means that I know that our answer matrix is going to be a 3 by 2 matrix. So I'm going to draw a 3 by 2 matrix. A 3 by 2 matrix has 6 cells. All right, so this is where things get kind of crazy. But you can do it. You can do it. I have faith. To do matrix multiplication, this is what row and what column. This is the first row, and this is the first column. So for me to do matrix multiplication, I need to take the first row multiplied by the first column. So my first row times my first column will give me the number that goes in the first row and first column. Well, how do we multiply? Don't ask me why this works. I have no idea. But it's the first term times the first term. So -1 times -3 plus the second times the second. 3 times -4. -1 times -3 is 3. 3 times -4 is -12. 3 plus -12 is -9. So this is -9. Easy, right? All right, let's try another one. Let's talk about this position. What row and what column is this? This is row 1, but column 2. So now I'm going to go back. I'm going to circle row 1 again, but this time I'm going to multiply it by column 2. So I'm going to take the first thing and the first thing. That's -1 times 2 plus the second times the second. 3 times 1. So -1 times 2 is -2 plus 3 is 1. So now I'm going to take that 1, I'm going to put it in that space. Getting the idea, you think? Let's try another one. What position is this? This is row 2, column 1. So I'm going to circle row 2, and I'm going to circle column 1. Row 2, column 1. So that's first times first, 4 times -3, plus second times second, -2 times -4. So what's that? -12 plus 8 would be -4. All right, let's pause here and see if you can try the next one. All right, let's see how you did. So this is row 2, column 2. So I'm going to circle row 2. I'm going to circle column 2. So that's 4 times 2 plus -2 times 1. That's 8. Take away 2 is 6. I'm going to encourage you to pause here and try to do the rest of this on your own. row 3, column 1, row 3, column 1. 5 times negative 3 plus 0 times negative 4, negative 15. And then last but not least, what color could we go with here? Maybe purple. This is row 3, column 2. Row 3, column 2. So that's 5 times 2 plus 0 times 1. 5 times 2 is 10. So we can check our work. Since there are no variables in this problem, we can go right to our calc. So I need to first, I'm going to use old school calc. So I'm going to go second matrix. I'm going to edit. This is a 1, 2, this has 3 rows by 2 columns. Negative 1, 3, 4, negative 2, 5, and 0. Second matrix, I now need to make my second matrix, which is a 2 by 2. Negative 3, 2, negative 4, 1, quit out. And I want to do alpha A, sorry. Second matrix A times second matrix B, and we should get negative 9, 1, negative 4, 6, negative 15, 10. So you might say, why the heck did we do all that work? Well, yet again, if I throw a variable in there, you're out of luck. You can't use your calculator to finish this off. So, all right, let's try to do this now with our calculator. So let's talk about the x variable first. So remember how matrix multiplication works. It's row times column. So I'm not just going to circle this x because it's more than that when I calculate with matrix mult. So I'm going to take this row. This is the row that I'm going to need to work with to be able to find the x value. Now here I'm going to circle, this is a row. In this matrix, I need to circle a column. The problem with the column is if I circle column 1, I have an x variable and I have a y variable. I don't want one equation with 2 variables. That's not good. So I can choose whichever columns and rows that I want to use. I'm going to use row 3 and column 2. So row 3 and column 2 would come together to make row 3 and column 2, which is the negative 3. So that's what I'm going to use to build my equation. So negative 5 times negative 3 plus x times negative 6 should end up being negative 3. When I do this row multiplied by this column, I should get this term. Now this is something that I can start to solve. Negative 5 times negative 3 is positive 15. X times negative 6 is negative 6x. Bump over the 15, that's negative 18. Divide by the negative 6, and we would get x equals 3. Now I want to find the y. So in this case, it's because this is the second matrix in the multiplication, I need to circle the column. So I'm going to circle the column that has y in it. Over here, I've got to pick a row, and it doesn't matter which row as long as it's a row that doesn't have a variable. So I'm just going to choose the first row. So this is the first row times the first column should end up giving me the term in the first row and the first column. So we're going to do our matrix mult now. 4 times y plus negative 5 times negative 6 ends up being 50. Clean this up. 4 times y is 4y. Negative 5 times negative 6 is 30. Subtract the 30. Divide by 4. We get y equals 5. If you wanted to, you could check this. I'm going to actually check it using my fancy calc. So we think x is 3 and y is 5. So I can go alpha F3. I want to make a 2 by 3 matrix. No, I want to make a 3 by 2 matrix. And you know if you're wrong because it doesn't look like the matrix that you're trying to build. -1, -1, -5. X we said was 3. I want to multiply by. Now I'm going to go alpha F3 again. This is a 2 by 2. So we said Y was 5, -3, -6, -6. 50, 18, 1, 9, negative. All right, that one worked out. All right, folks, so there's some stuff you can do on your calc. There's some stuff you have to do by hand. I don't mind if you use the calc on the ones that you can get away with it, but the rest, you do still need to know how to do it by hand, be able to attack. I'm telling you right now, there's a problem just like this on the test, and there's another one just like this. If I were to make a prediction, this is something that, I don't know, 50% of the kids or more get incorrect because they don't remember how to do matrix mul by hand. All right, good luck. Go get that homework.